Yeah, so I think that we will start. I would like to welcome you to this afternoon's webinar on hygienic design with a specific focus on EHEDG, guidelines, and certification. I assume that most people here will know what EHEDG stands for, but it is just to make sure everybody's on the same page. It's the European Hygienic Engineering and Design Group. We are so lucky that some of you have already interacted with us beforehand. So we got some questions, and I will try to address those questions along the way. My name is Alan Fries, and I have a long career with hygienic design and food processing. And my current job is to head the hygienic test facility and providing consultancy on industrial hygienic design here at Force Technology. Previously, I've been active in a lot of research projects, Denmark, the Nordic countries, EU, and I've been writing papers and books, chapters, and so on hygienic design. I've had a special focus on computational fluid dynamics to use for optimized cleaning. But at present days, I'm mostly active on the international scene in EHEDG, and I'm sitting in a couple of working groups with EHEDG. One being training and education, where I am spearheading an initiative on new training methodologies, where we're focusing a lot on e-tools for learning in the field of hygienic design. I'm sitting in hygienic integration as well as a working group on open processes. Then I am authorized evaluation officer by EHEDG, and it is in that capacity I will speak about the certification schemes of EHEDG at a later point during this small webinar. And I'm also authorized by EHEDG to conduct training according to their training material. So I've been at the Technical University of Denmark for the majority of my professional career. Had a break out in my own company for 6 years, and briefly back at the Technical University, and now I am, as I said, at Force Technology. The agenda for the webinar today is just a short presentation of what we do here at Force Technology. Some insights into hygienic design from a helicopter perspective. Then I will dig into EHEDG guidelines, some of the groupings of these, and there are some of the questions we got for today actually pertained to the guidelines, so thank you very much, and I will address those when we get there. And there are also questions already that address some issues of certification, so I will also get back to that. After each of these sessions, small sessions, there will be an opportunity to ask questions, and we will also have ample time for questions in the end of the webinar. So just a few words about the Center for Hygienic Design here at Force Technology, and we are building, because it is rather new here, building a knowledge center where the industry can get access to the latest news about hygienic design and product safety. So that is a strategic activity for us in the years to come. We have naturally, I would say naturally, because hygienic design is mostly a food industry topic. So that's the basis for us. But we are increasingly moving into biotech and pharma industries, where we can see that the need and the interest in hygienic design is growing. So if we look at just before, there can be many other objectives, but the hygienic design as an activity itself, cleanability as a very important industrial parameter, but also lifetime of process equipment to get a better lifetime, also a better cleaning performance is some of what we are addressing. And on top of that, trying to help to optimize the cost of ownership. So that means making cheaper processes that perform at a high level of safety during a hopefully long lifetime. So that is our focus. And then I can share a little bit of, I mean, this is breaking news. There should have been a yellow bar running across here because we are, as of this week, officially been accepted as a testing laboratory, accredited testing laboratory by the European Hygienic Engineering Design Group. And we've been working hard on that for the last couple of months. We are the only one in the northern part of Europe. And part of the whole process here is also that we are accredited by DANAC. So we have an accreditation both from EHEDG and DANAC. The EHEDG services that we're providing is evaluation certification, which I'm getting back to, of hygienically designed equipment according to the guidelines, which I also come back to. And we are performing, and that's where the accreditation comes in, testing for cleanliness of closed process components by the EHEDG method, which I will also talk a little bit more about. And some of you may think that mean, okay, but were you not already an accredited test laboratory? We were until the end of January. Indeed that when we were at the Technical University, but now 4 months later, we are back on the scene as accredited test laboratory now under the wings of FORCE. So we're very happy, and I will also announce a little bit of an event when I come to the end. I mean, we don't have a lot of time today, so hygienic design is normally something that could easily be a 2-day or even 3-day course. So I will try to get you through some of the basic activities. Looking at this slide, we have the vertical activities here, the vertical areas, parts, building modules, units, lines, and areas, which are sort of the traditional activities that people have been performing and trying to incorporate hygienic design in. But what we also know is that if you want to be able to perform at your best, you also need to learn. You need to have feedback from projects and factories already built back into the system so that you can do the design loop better when you are repeating that, but also in order to make the right descriptions and set up the right criteria for cleanability, you need a bit of a top-down approach as well, because it matters a lot if you can clean around the equipment that you put into a factory. It also matters how you clean the envelope on the inside, so how you clean the walls, even the ceilings, but especially the floors in a production facility. So everything here is something that you will have to visit and also revisit. And I will come back to a model that would give a little bit clearer picture of how you're actually interacting and also sometimes iterating when you go through a design process for a new plant. This is actually the only picture that I'm going to show today about how hygienic design and what can go wrong. And as you see out here on the right-hand side, there is a pump installation from the industry, and this low pump is actually here installed in the correct way. We look a bit to the left, to the middle picture here, seeing that when we are looking inside the pump, that we can actually drain the pump. Had it been turned to this position that we have to the far left on the slide, then there would be a sump of fluid that we cannot drain from the bottom part. If this was a pump that was installed somewhere where it would be taken apart for cleaning every time, this may not be a big issue. But the thing is that here we have, this is a pump, and it could very well be one with an EHEDG certificate. But you can see that you can easily install a certified hygienic component in a wrong manner, and then you can still hamper the hygiene of the entire system. So we need to know how to make the components hygienic, drainable, and so on, but we also need to know how to combine them. So that, I think, is one of the more tricky and steps in hygienic design and hygienic integration, because not everything will be on an installation drawing, and not everything in a process will have sort of be described in the same detail, having the same light thrown upon them. So that can really sometimes leave the decision up to the people doing the practical installation, which is not the best way to optimize hygienic design. So one of the topics that EHEDG has been promoting, and one I can say I'm proud of being a part of, that is hygienic integration. Because what we are doing is a lot of, let's say, different, not necessarily noticeable decisions that will lead to procedural errors when we are building process plans. And what we would like to do is, of course, to have a way of circumventing making these errors, and that is by doing hygienic integration. So whenever we're combining two, that could be a pump, putting it into a piping, then we would add a tank. We would all the time be interacting and evaluating, is it drainable? Is it cleanable? Are we introducing hazards while we do that? And now it seems like there's a lot of documents to keep track of, and I would say that is correct, because when you are making a new plant, you have a lot of different activities, from gathering the user requirements, specifying a functional design, detailing design, which we have here on the left-hand side. And we also know that we are sort of writing specification in greater detail. We've got that, but also sometimes we know that we're changing something along the way. So we need to go back and actually validate, is this within the window of the original user requirements? And alongside this, there needs to be a documentation. Documentation sometimes is a pain, and it may sometimes also kill creativity in projects. But when we're talking about something that is hygiene critical, then when we're moving up the right-hand side here, where we want to qualify the installation, the operation, and the performance of the plant, we need to be able to test back towards the design and the functional requirements, the user requirements, and that requires a test plan. And that test plan needs to be adapted to what is actually there in the plant, and not what you would have wished for when you started out in the first place. So the V model, as this model is called, which is a systems engineering model, there can be other models, but this model is one that we are increasingly promoting in EHEDG. So it's an integral part of the integration guideline. It is also in the validation of CIP systems, and it is one that we will be promoting more and more in the future. So this is the this is a structure that you are doing your project planning, your project execution according to, and then it will be easier to do all the testing, all the qualification when you're moving up here. What is not on this figure here, but what could very well be out here, is actually that we will move into production. So we could up here also have an activity which is also a very important hygienic design activity, and that is maintenance, making sure that the plant will remain hygienic in its lifetime. So this is a model that we will be coming back to in the coming years and try and build a better overall activity around hygienic design and product safety. Risk assessment is pivotal for good hygiene in practice, because risk assessment is the activity that will allow you to find out, are you doing enough to prevent likely risks from occurring? But also sometimes would say that some activities may not be necessary. So the risk assessment is actually also sometimes saying that there could be risks that are more hypothetical that we may not need to address. So a risk assessment is very much specific to the actual product, the actual process. So a good risk assessment and a powerful risk assessment is one where the limits of a process is well known. This is part of the legislation. This is part of 1672/2, which is supporting the Machinery Directive. It is not mandatory, but it is mandatory to have some kind of risk assessment before you can CE mark a process when you are in the EU. Cleaning is also important, and I mean, these are just the 4 parameters of cleaning. We have the temperature, the chemistry, time, and mechanics. And hygienic design is a lot about, say, optimizing the mechanics, so you get the cleaning agents to the surface, get them to act there, and also make sure that the access is in a timely manner, so that you're not using time first to access the surface and then perform the cleaning. That will prolong cleaning time. So cleaning is performed best on an accessible surface. So when we're talking about hygienic design, 2 basic principles is drainability that I talked about earlier, and accessibility. And of course, cleaning on a surface which are not polluted by residues, visible residues, then it is difficult, if not impossible, to perform a proper cleaning. And I'm just bringing this slide to show an example of what could happen if you are relying on steam as a sterilization activity for making sure that you have the right safety. So we have the purple curve here. That is the temperature of the steam on the surface. That would allow us to assume that we have the light blue line here as kill or microorganisms. But if we have a crevice which is just, and there's a microorganism sitting there, a little bit retracted, then it would take time for the temperature, maybe just half a minute, before the temperature starts rising at the bottom of the crevice, and the temperature curve will be more like this one. So it will take time. And that will mean that we are getting a lower kill of the microorganism. And it means this is a logarithmic scale, the kill of the microorganism. So you can see this, if this is the actual sterilization effect, that would be the difference between success and failure in many processes. So I'm saying this because actually nothing really is a substitute for good hygienic design. So make sure that there are no places where microorganisms can hide, both during cleaning and other sanitation processes. So this was a very short go through of some of the basics of hygienic design, and it would be time to answer a few questions if you have any. Satya, has anybody asked questions in the chat?
So far, no questions.
No. Okay. This would be the time then for me to address. There were two actually very good questions. One about cleaning tool selections, a guideline for that. And I would say that that would probably more be a question for some of the cleaning actors like Diversity or Ecolab to answer. And if it is something that you would like answered, then I can provide you contact with some people at Diversity who would probably be able to do that. And then there's a very specific question about wash down of equipment which are mostly soiled with fatty products. And I would say that's a little too long to address in this short webinar. So whoever's been interested in this, please write me an email afterwards, and then we will look into that and see if we can help you. But then I will continue and talk a little more about EHEDG, some of the basic principles and the guidelines. And EHEDG is a private, not-for-profit organization, but they are, of course, operating on commercial basis. So that means that everything, the guidelines, the training, the conferences, and all these kind of things will be on a paid activity basis. So, but right now, the guidelines of EHEDG, there are 44 active, and I will not go through all of them, but I will give you an insight to how they can be grouped, and also tell a little bit about where we are going. I will also show you some of the documents that are available for free download, and also just highlight that EHEDG is doing a lot for networking and building the community concerning hygienic design. And even though EHEDG is European, that's the first word, then EHEDG is international, and EHEDG operates worldwide. So the World Congress is really a World Congress. It should have been held in Munich here in October this year, but due to COVID, it's been postponed to June 2021. So besides the guidelines, EHEDG also developed test methods, and EHEDG certifies equipment, which I'm coming back to, and that is what we are taking part in here in our center. EHEDG also seeks continuously harmonization and alignment with the 3A standards incorporated, and we are continuously doing something there, and we have new activities that are starting up in this field. And it's so important that we have these two strong organizations providing information on hygienic and sanitary equipment, EHEDG and the 3A, that the users of all these guidelines and certifications, that they have some easy way of comparing the two and find out how to choose the best set of guidelines and standards to apply. The basic principles of the guidelines is actually just three areas which are very important but also easy to remember. EHEDG is based on rounding radii. They need to be 3 millimeters at least, so no sharp corners. Here 3A would say 3.2 millimeters, so if people are going for 3A, it is not a big problem to add a little extra to the rounding radii. Then there's a fallen surfaces, minimum of 3 degrees, and surface roughness, which is below 0.8 microns. So that says 8 micron. I will correct that in the slide stack that I will send you. So it's 0.8 and below 0.8 microns. That's the EHEDG criteria. Then EHEDG require availability for cleaning of all non-hermetically sealed areas. So it needs to be hermetically sealed if it should not be cleaned. EHEDG also treats all surfaces as food contact surfaces. So if a company is seeking EHEDG certification, it needs to comply to the surface roughness requirements, both on the on all surfaces where product can actually come in contact with the equipment. If there's a lack of hygienic design, that calls for special description of the cleaning procedures, and it may not, that type of equipment will not be certified. There are of the many guidelines of 44, I just picked 4 here that say are more sort of basic guidelines, and it's Doc 8, which is it's the constitution of EHEDG. I'm coming back to it in a slide. That is where we have all the basic criteria that you must comply to. Hygienic design of closed processing equipment, a guideline that pertains to CIP cleanable systems. One on open, which is quite old, and we actually in the open equipment group revising this guideline at the moment. And then there's one on dry particulate materials, and in the EHEDG context, when we're talking dry, we say dry for dry cleaning. If you are combining dry production with wet cleaning, then it will be wet for all considerations according to EHEDG. So even though a lot of what EHEDG has produced cost money, then there are some things that are for free. There's an EHEDG glossary that is talking about the translation of wording between the 3A and EHEDG. There is an EHEDG position paper which is describing all the EHEDG approved process connections for combining equipment, but also for mounting sensors into processes. So if a sensor manufacturer is applying one of these, then you can actually apply all of them, ideally within a certified frame. So you are just getting one, the worst case, I'm coming back to that, one sensor tested as part of a certification processes. Then the guideline number 8 is for free, and so is cleaning validation in the food industry, part 1. That one is free as well. So if we dig a little deeper into guideline number 8, it's a short 16 pages, compilation of the normative references, the definitions, the basic requirements for construction materials, the functional requirements that I have already talked about, and a bit about sort of what is the basis, what is always going to be needed in order to make hygienic design. So construction materials, of course, we are looking into, we are in Europe for the main bulk of what we do. So compliance to EU regulations concerning construction materials, but we are also looking at, for that, the FDA requirements. So we are often, when we are dealing with non-stainless steel materials, we are asking for both compliance with the EU regulation and FDA. There are no pictures in this guideline, so it's a little bit dull, but it's only 16 pages, so it's possible to get through it. But all the pictures, they are found in the specific guidelines. So it's important to just say, here, guidelines are guidelines, they are advice. They are not legislation, and they are not standards. So I'm not going to say so much more about this, but just again here saying that we have EHEDG and 3A. Sometimes they may have developed into becoming more of de facto standards. So some people may actually call them standards even though they are not. So when we look at the standards, the guidelines, sorry, I do it as well. So look at the guidelines. So also questions to how are you going to address and assess with the guidelines in a structured manner? The guidelines are, and that is actually also possible to find those guidelines in on the homepage, divided into main topics: general principles, materials and surfaces, test methods, factory design, so everything that has to do with the outside of the equipment in one bucket, open equipment, closed equipment, and there's far more guidelines addressing something with closed equipment than there are with open. There's a bunch that address the dry particulate. There's a bit on packaging, filling machines, heat treatment, and something which is developing and growing, the cleaning and validation group. So these are some main groups, and when you go into the EHEDG homepage, you can get the guidelines by number, but you can also get them by grouping. And that will make it a little easier to find out which ones to look at and potentially buy. I have here for reference, and I'm not going to go through all of them, but just say, these are the guidelines. You can see some are crossed out, and that is because they have been revoked over time. Some are included in new guidelines, and some are simply revoked. And I will sort of flip through here and go towards the end, because a lot of these guidelines are on the sort of the left-hand side of the slide I started by showing, with the vertical activities in hygienic design, and moving a little bit towards the end here, where we have some more activities that are horizontal. We have the integration guideline, and we have here also design principles, equipment for process areas for aseptic food manufacturing. And moving to the last page here, we also have here 44, design of principles for food factories. There's cleaning validation. I spoke about that earlier. But we also have one here. We should not forget the guideline on air handling in the food industry. But here also the hygienic design requirements for CIP installations. You can also see here that EHEDG has recently also moved into making guidelines that are addressing specific food groups. I think that we will see more of that, but we will see more guidelines also addressing the horizontal, the integration aspects, how to put everything together in something that would be more optimal as a working unit. So that would be some of what we will see with the EHEDG in the future. So Satya, has any questions popped up?
Yes, we have two. One is
Good.
from Dennis, and he's asking, is there any guidelines to limit the reuse of cleaning solution? I mean, if the client wants to store CIP SIP solution from one system cleaning procedure, which it was conductively tested, and
Mm.
reuse this stored cleaning solution in the follow SIP process.
Then there's definitely knowledge out there. There is no EHEDG guidelines that deals with that at the moment. I think that also where EHEDG is trying to, at least today, sort of make the draw the line, is not to get too much into something that will be too specific for a certain application. So that also addresses, that was one of the questions asked beforehand. Has EHEDG published a guideline on COVID-19 prevention in control in food processing? And EHEDG has not done that. So it also says that developing an EHEDG guideline is something that takes years. So COVID would be long gone before we would be done with a new guideline. But you had another question also?
Yes, it's from Marian. I heard that EHEDG is working with certification standard as BRC, IFS,
Yes.
FSSC 22000 in order to get some hygienic design requirements into these standards. Do you have any further information when and how that will happen?
I do. I do have information. I'm actually sitting in a task force. I could have said that as well. So I'm sitting in a task force dealing with the EHEAD side of that. It's fully correct what you're saying. The thing is in a little bit of a gridlock situation, because what it seems like is that TFSI they're definitely not going to make the new scopes. They call J1 and J2. They are not going to make them compulsory. So it will be voluntary. And EHEDG has been part of the process, but right now we don't know how the GFSI will end up publishing a guidance document on hygienic design. What we do know, and that is where we are working with all the CPOs and the BRCs and the IFS organizations in order to be a part of making some of the more practical solutions, also training auditors and so on. So we're very much there, but it's something that is developing as we speak. We almost have a web conference every week. So I would be glad to keep you updated, Marian. And it's something that we will definitely be writing about in the future. Very, very interesting and hot topic, definitely.
She's saying, I appreciate your updates.
Thank you. So, so the last part here is about certification, and one of the questions, and I can take that up right now, is how to determine when a piece of equipment is in scope for EHEAD certification. And I will hope that I will address that during my my talk, small talk about certification, because there are strict limits. I mean, something that needs to be certified needs to be of a small size. I mean, the biggest is like a 3-inch twin screw pump or a double diaphragm pump or something like that. But it's a functional unit. As soon as it becomes a line or it just stretches out to combine more than one module, it is not really possible. So, but I hope that I will come around everything that is relevant. Otherwise, please ask after my my short go through. Oh, so when you want, you desire, and you think that EHEAD certification may be something for you, then the first is to address an AEO. That could be me. and have a discussion. And actually, we see more and more companies coming and say, we are developing something new. What would we have to do to make this eligible for EHEDG certification? And a lot of what we do in the beginning is that we're just looking at 2D drawings. They are also part of the certification process when we get there. The next step will be looking at a physical specimen. And of course, both the drawings and the specimen we have evaluated according to the guideline criteria. And that is no matter what type of equipment it is. Then we're going into 3 areas that are closed equipment, and that's where we have the best ability, because we can, besides evaluating according to the drawings and the physical specimen, we can test. So we can say, this seems to be so close to what we would expect, but there are of a hygienic piece of equipment, but there may be something for functional requirements. That could be a mechanical seal sitting in the back end of a pump. I would say, how will it perform? So we would test. And that is the strength of the EHEDG certification that no other certification have, because other certifications are done purely theoretical, like the 3A, looking at drawings and trying to evaluate the functionality. But we can actually put a piece of paper, a test report on top of that to say it actually works. But that's, as it is now, only for closed equipment that we can do that. Open equipment, there's no test currently. There's one being developed, but it's a little time away. And for the outside auxiliary equipment, also we can certify that, but there's still no test. And I've been through what we're evaluating for, but I would say a couple of other things that are very important here. That's O-rings, O-ring grooves, and we are actually preferring foam seals over O-rings today. They have a better hygienic performance. So when you have a piece of equipment and you would like a series certificate, so that could be pump sizes from 1 inch to 3 and even larger dimensions. The biggest pump that we can test is a 3-inch pump. That is the largest that has been tested in the EHEDG certification and testing scheme. But there may be issued certificate for larger equipment if they are similar to those that can be tested. So we would be looking at to select the worst case or cases and test those. So depending on the component, we're looking at operational data, geometry. In some cases, if it is pretty sort of straightforward flow-through devices, that could be flow meters, something where there are small contractions, expansions, we would like to get CFD simulations to assist. But in any case, what we're looking at is similarities and differences. So sometimes, for example, smaller dimensions of a flow meter may be similar in the design, the larger be in another group, but similar. And in that case, we would say we would need to select a worst case from both families, test that before we give a series certificate. So a worst case can be more than one. This is a cumbersome process. We do a lot of discussions in the group of AEOs. So whenever we're making decisions, we are registering that in a log file. And we have them for future discussions, but also to consult in the best manner possible with new customers. Then there's the issue of recertification, because EHEDG certificates has a lifetime of 5 years. And after that, there need to be a recertification. But if something is going to be tested, again, this is something that more AEOs will discuss. There's not a single AEO sitting saying, okay, we need to do retesting because that is a good income. No, we will actually go a long way to actually use old test reports if that is at all possible for issuing people's next certificate. So the certification schemes, and I'm not going into detail here, but we have the liquid EL, that's the liquid, and there we have basically just CIP systems, we have aseptic systems, and we have in the middle here the class 1 AUX, which is auxiliary. So it's equipment cleaned wet, but outside the process. And we have two subclasses, and one, and that means something which is cleaned in place. You can see here, cleaning without dismantling, and we have class 2, cleaning with dismantling. So that can be in the CIP class or the aseptic class, but we're not having one for auxiliary where it can be allowed to be taken apart during cleaning. So there's a bit about which guidelines we're looking through. Then we have similar to that, we have a dry certificate scheme, ED for dry process. And there again, we have a class 1 and a class 2. So one that is cleaned in place, one that is allowed to be dismantled. For both the EL and the ED, if we're moving into the class 2, it is like class 2 is not something you apply for if you don't pass class 1. Class 2 is something where you go in and say, but we have something here, and it's easy to understand with the dry processing, a rotary valve, we take it apart during cleaning. That is actually, it will be in the class 2. So it needs to be taken apart. So it's not an escape route for not passing class 1 that then you just move to class 2. You need to start with class 2 if that is what you want. Then there's just a few words on the test method that we are running. We're testing cleanability and comparing that to a straight pipe. So we have some reference pipes with a well-defined roughness. We are soiling both equipment and reference pipe with buttermilk with a thermophilic bacterial spores. We're putting pressure to the system and we're drying it. And then after that, we're cleaning with a mild EHEDG detergent. Following that, we will incubate with agar, and that is to grow any remaining spores after cleaning. And what will happen with this agar, it's purple. But if there are microorganism spores present, there will be a pH shift and the purple agar will turn yellow. And the test is valid when we have between 5 and 30% of yellow discoloration in the reference pipe, because we need something to compare to. Otherwise, it is impossible to validate the method. And a piece of equipment passes if it has less yellow discoloration compared to the reference pipe. Have that in 3 tests out of 5. And whatever yellow discoloration that may be in the test item, it needs to be randomly distributed for that equipment to be certified. So that is certification in one slide, or testing for certification in one slide. Just a few pictures. My colleague Maria in the test lab. Up here, you can see purple agar being filled into a reference pipe. This is a reference pipe unfolded. All the yellow areas here are being counted and a percentage calculated how much yellow is here. And there's about 15%, I think, in this one. From the the opening of the reference pipe and a few more processes. And also every time we run the test, we are checking that our microorganisms are functioning as they should. So this was perhaps a very fast go through of EHEDG certification. But nevertheless, I hope that you got a glimpse into the process. Satya, do we have any questions from the audience?
No more questions.
No more questions. Okay. Then I can say that following this webinar, we will send you an email. There will be an opportunity to sign up for a newsletter. There will also be a button you can press if you would like a consultation with me or a colleague, just a one-on-one call, a Skype meeting, whatever, if you find that relevant. I will also highlight here that we're having a hygienic design course, which is our basic course, running in September 1st and 2nd in Brøndby, and then we're later doing it again in Jutland in Vejen on November 10 to 11. So that is our regular course, but we're also happy to discuss with companies to make in-company training. I gathered some links, useful links to the EHEDG homepage, the EHEDG Connect, which is EHEDG newsletter, that will bring stories about hygienic design in EHEDG, the use of EHEDG, information and why people are active in EHEDG. A link to the free documents, but also a link here to the page for certification, and just a couple of links to our homepage so that you can see a little bit about what we are doing on hygienic design. Then I will also, this is again something that has not been spoken so much about because we were waiting to see if food tech would be organized as planned in Herning in September, and it is going to be so. So we have for some time been planning to make an EHEDG symposium there on September 29th. And we have already a couple of confirmed speakers. So we have Hein Timmermann from Diversity, and he's the chairman of all the CIP activity. And we have Roland Cocker, and he's the chairman of the integration subgroup. And on top of that, we will be focusing and having a lot of other presentations for more locally innovation in cleaning and disinfection, but also focusing on systems design and whatever is new with hygienic equipment, hygienic design, and focusing on the oversight, the project design and monitoring. Still, if there are any questions, of course, I will answer them, but thank you for participating. And if you're interested to have a look into an EHEDG test center, we are doing a virtual opening with a live video link next week, Wednesday, June the 24th at 3 p.m. An invitation will also be in the follow-up. So that will be a chance to look into an EHEDG test center and get a little more detail explained about how we are doing stuff there. So we're looking forward, hopefully, to see some of you at the virtual opening, or also again here at the EHEDG symposium during the food tech exhibition in Herning. So, but Satya, any more questions come up?
No.
No?
So, yeah.
There's a chance, even for people to open their mic and ask a question. We're bold today.
Yeah. You're welcome to unmute themselves.
Yeah.
Otherwise, we can't mute them all.
But otherwise, the opportunity to book a one-on-one is possible when you get the follow-up.
Yeah.
Okay, but then I say thank you for participating. It's been a pleasure. It's always a great opportunity to talk about EHEDG and highlight a lot of what is going on of good stuff in EHEDG. So hope to hear from some of you soon, and have a nice day.
Yes,
Bye-bye.